Hello, let's do some math for fun. This is a question from the 2001 German Math Olympiad. We are going to find real numbers q so that this equation has 4 real solutions and we want the solutions to form an arithmetic progression. Meaning that we can start with a smaller solution and just keep adding the same numbers 3 times and we have all the 4 solutions. Right? And as always, please pause the video and try it first. And Pikachu will be with you guys. Got it? Great. The answer is 144, by the way. Alright, here we go. Let's see how we can solve that. First, we notice that this quartic only has 3 terms. And we can actually change this into a quadratic after a substitution. So let's go ahead and do that. So let's go ahead and say let u, let me just pick u for that, to be x squared, right? Then the original equation, I will just put that to be star. Then our original equation, this right here, will be equal to u squared minus 40u, and then we still have the plus q, and that's equal to 0. And here we have a quadratic equation now. It's much easier to deal with, right? And of course, there's a connection between the solutions here and here. Well, this has just 2 solutions, and we have to make sure that these 2 solutions are both positive, because later on we will have to take the square root of the solution right here to get the solutions of the original, right? And also the solutions of course have to be real. So here we go. Let me just say that I'm going to just call the solutions right here to be R1 and R2. And be really careful with this though. Can R1 and R2 be equal? Not so much, no, right? Because if they are equal, then that means the solutions right here will be equal. That means you don't really form an arithmetic progression if they are all the same number. That's not fun, right? So right here, when we say R1 and R2 are the solutions, first we are making sure that they are both greater than 0. And I'm just going to pick one to be bigger than the other. So right here I will say, assume R1 is less than R2. And again, they cannot be equal. That's the conditions that we are setting up. So R1 and R2 to be the solutions to this equation, and I will just put that to be star, star, like this. So just put on star, star, like that. Right? Great. Then, what can we do with this? This is the quadratic equation in the standard form. Once we know the roots, we can actually change that into the factorial form. So, then we can write star, star as, well, I'm just going to write this down as u minus R1 times u minus R2. And this, again, still have to be equal to 0, right? And once you put this into the factorial form, you can multiply this out and you can actually equate coefficients. And you can see this right here is going to give us u squared, and this times this is negative R2u. This times this is negative R1u. I can combine them, factor out the negative, so that we get negative parentheses R1 plus R2, and then we have the u. This times that is plus R1, R2, that's equal to 0. And perhaps let me just make the R1, R2 red as well. And now, this right here and now of course are the same thing, in the sense that we must have R1 plus R2 to be 40. So you see, this is one way to come with some connection. We want to make sure R1 plus R2 to be equal to 40. And in the meantime, R1 times R2 has to be equal to Q. And in fact, this is also called the Fiat formula. Now that's just a little proof for that, right? Great. So now what? All right, again, R1, R2 are the solutions to this. We still have to relate to the original, right? We still have to face the original equation. All right? What are the solutions to the original equation though? Well, we just have to take the square root of R1 and R2, and don't forget the plus minus. That's all, right? So right here, notice the solutions to the original equation, namely just the star, are, well, look at that, and we just have the plus or minus square root of R1 and also plus or minus square root of R2. And now let's play a game. The game is called put a smaller number first. We have 4 numbers right here. Which one is the smallest? The answer is negative square root of R2. Why? Because R2 was bigger than R1, right? If you take the square root, the inequality stays. But if you have the negative, this right here will be the smallest. So we have this, and the order of the solutions are going to be this, and then the next one is negative square root of R1, and then the next one is positive square root of R1, and the biggest one is square root of R2. So they are in this order. Not only that, we want these solutions to form an arithmetic progression, meaning that I need to be able to add a number from here to here, and let me call the difference to be d. Add a d right here, we can get that, and likewise, if we add d to here, we will get this, and then if we add d right here, then we get that. So we want the common difference. Alright, so this is all good, but what can we do to find out the d, or maybe R1, R2? What do you guys think? Just try out? Okay, let's see what we can do for that. Well, one thing that I know is, if I do this minus that, if we have square root of R1 minus the previous term, which is negative square root of R1, this right here has to be the same as d. And let's solve this real quick. This is just 2 square root of R1 is equal to d. I can divide the 2 on both sides and take the square on both sides. So you can see R1 is equal to d squared over 4, like this. And similarly, I can say, well, this right here is R2, right? Square root of R2. And how can I do that? Well, I can write it down like this. I can say, let me start with negative square root of R2, and then let me just add a d 3 times, so plus 3d. This right here will give me square root of R2, right? So that's pretty nice. And now let's do this in your head again. Add this to both sides, so we have the 2 square root of R2, divide the 2 on both sides, and then take the squared on both sides. R2 will be d squared over 4. And of course, I forgot the 9, because 3 squared is 9, so this is what we have. Now, what else can we do? Well, R1 plus R2, which is this plus that, is equal to 40, isn't it? Yes, it is. So all we have to do is, because R1 plus R2 is equal to that, so I'll just put down R1 plus R2 is equal to 40. This means we just have to do d squared over 4 plus 9d squared over 4. This right here has to be equal to 40. And you can just do this, you can just do that. In the end, you will see that d is equal to 4. And again, just solve the equation, and this is not so bad at all, right? And once we know d is equal to 4, now what? Well, I can just put a 4 back here, and we can figure out R1 and R2. So with that being said, you will see that R1 is just nicely equal to 4 squared over 4, and that's 16 over 4, so that means R1 is equal to 4. And then R2 is just 9 times 4 squared, and then divided by 4, that's 36. Yeah? Just like that. And finally, what do? I want to figure out q, right? Don't forget about our original intention. And q is precisely R1 times R2. So I'll just write down q, which is the same as R1 times R2, and that's just nicely equal to 4 times 36, and the answer is 144. Wow, I finished everything on this two little boards. So the answer is 144. So you guys can just start zooming right here a little bit. All right. So Pikachu, you approve? Yes. Right. Great. Pikachu approves this right here. So we're all good. So I think that's it. And if you guys have any questions or any comments, just leave a comment down below and let me know. All right. Thank you guys so much for watching. I'll see you guys in the next video. Bye.